Semiconductor development is driven by tight timelines, where engineers rely on fast, familiar verification methods to stay on schedule. Addressing security should be no different. Security checks must be accessible and integrated into existing development processes early, where issues are easier to fix. To this end, CASP is pleased to provide CODAx, our static security checker designed for functional development teams to help adopt secure by design practices without disrupting their flow. CODAx allows security verification of over 100 dedicated security rules in early RTL design code that runs in a fast, push-button manner. This enables the identification of security bugs early, with CODAx guidance to fix the security issues as well. These checks complement what is already happening in the static domain with functional and structural linters, but now provide users security checking capabilities. This also enables the generation of auditable evidence for designs, and it sets users up for deeper analysis with further verification tools. This is important in the semiconductor industry where there is constant pressure to deliver quickly and efficiently. As design complexity increases, so does the verification workload. Yet, most efforts remain focused on functional correctness, leaving critical security risks overlooked. Early stage security weaknesses, if left unchecked, can turn into serious threats that the evolving security landscape can take advantage of. Organizations may already have internal databases of weaknesses, vulnerabilities, and threat models for security verification, but this is not exhaustive. It's also not easily deployable to check across diverse and evolving designs at scale. This requires early and easy checking where engineers can identify insecure features through quick but powerful techniques. Static verification is a capable approach to enable security auditing of early RTL design code and provide guidance to fix the issues. However, there has existed little to no comprehensive static security rule database dedicated to security checks, meaning user expertise and manual reviews are still required. This is where Caspia Technologies' CODAX solution comes in. CODAX is a static auditing tool that automatically checks for insecure design implementation practices. This can raise concerns for confidentiality, integrity, and availability problems for chip data related to both control flow and data flow parts of the design. CODAX includes an internal database of security-specific rules that can run in a fast, push-button manner through static verification. This will identify coding violations of those rules as well as provide suggested fixes. These checks are derived from numerous sources, including the Common Weakness Enumeration Database, as well as Caspia's unique knowledge of the hardware security field, built off 2+ decades of research in the area. We map each check to the source information and tag with corresponding attack mechanisms to understand exploitability. Please see the table in the bottom right for some examples. Additionally, certain checks are tied with specific design assets and security attributes to provide more localized results. We keep this database updated constantly with new checks as more information is released to the community and as we perform our own research, including the use of generative AI and LLMs to develop new checks. Now, to further demonstrate CODAX's uniqueness, we'll step through the usage of the tool and the results that we gain with an open source and well-known benchmark, OpenTitan. This is an established hardware root of trust that is constructed of over 30 IP blocks and over 300,000 lines of RTL code. To use CODAX, one will need to provide the HDL code as well as any input regarding the associated threat space. This will help wave and tune the associated security checks that CODAX will perform to provide valid and meaningful results. These results will then include the location of any rule violation in the code, with messages explaining how the violation was detected, as well as provide suggested fixes to help the user go in and improve these areas. The rapid nature of static verification allows users to quickly iterate on fixing the code before making any final commit. This process also helps produce documentation and evidence of checks performed that can be version tracked and maintained alongside the design. Now, to use the tool, we'll open Caspia's unified platform interface for our security verification tool suite. We'll create a project dedicated to our analysis and include our design files. We will then run a CODAx session, and here we can tune the verification parameters, such as specifying any known security attributes and pre-waiving any of the checks we want to perform. We'll then simply click Run. This should take seconds to minutes depending on design size. We will then see as an output the identified violations, where those violations occur, and further information on each of the violation and why they are a security concern. With this analysis, we can identify potential weaknesses that are tied to specific vulnerabilities. For example, in our case study benchmark, we identified insecure state transitions between protected and unprotected states within a security critical module. This creates a fault injection susceptibility, where if a fault is injected, unauthorized access to a secure state can be granted. With this information, we can eliminate the issue with the suggested fixes provided. Now, we do see other static verification tools in the market, such as linters, but these have a focus on functional and structural bugs. The security checks that CODAx provides are meant to complement these with security. These other tools either don't have security-related checks, or they have certain similar checks but without security explanations. If you do try to analyze these, you must comb through all of the outputs and make the decision yourself if any violation is a security concern. This could mean examining thousands of messages to identify that one security bug. Whereas with CODAx, you have unique security checks and you know each violation is a security concern, giving you dedicated security feedback and reducing reviews and fixes from hours to minutes. The CODAx checks go beyond isolated one-time validations. The robust database of static rules enables users to check their large design for a variety of concerns. Included here is a summary of recent benchmarks. Static verification enables rapid checking and iteration, allowing the reduction in security weaknesses before they turn into greater concerns. On the roadmap for CODAx is to have unique, intelligent capabilities to provide security information automatically. This will help reduce the user in the loop to provide automated waiving of rule checks and identification of assets. This will provide even more targeted analysis. This capability, along with CODAx's static engine, will also help feed valuable information to Caspia's next-gen solution, SVX, which is a GenAI-powered security property generation tool. Running static analysis before running the GenAI capabilities allows easier and faster identification of critical design elements and streamlines deeper security checking, making these a valuable pair. Please reach out to Caspia to learn more about the CODAx roadmap. With CODAx, you are able to retrieve fast, push-button analysis of static security checks at one of the earliest development stages, where it's easier and less costly to fix. It helps equip engineers with security expertise and ensure secure by design.